In this problem, we need to obtain the derivative of e raised to the power of the inverse tangent of square root of x. So we know that derivative of an exponential function gives us the function itself. So that means derivative of e raised to the power of tangent inverse of square root of x. So that will be e raised to the power of tangent inverse of square root of x. Now we have to apply the chain rule. So that means we multiply it to the derivative of the inverse tangent function. Now we have the derivative of the tangent inverse function. So that's simply 1 divided by 1 plus x squared. So let's apply this. So we'll get e raised to the power tangent inverse of square root of x times. So we have tangent inverse of square root of x. So that will be 1 divided by 1 plus. So instead of f, we have square root of x squared. Again, we need to apply the chain rule to square root of x. So that will be multiplied to derivative of square root of x, which is simply x raised to the power of half. So here we can apply the power rule. So our power rule is derivative of x raised to the power of n with respect to x. So that's n times x raised to the power of n minus 1. So that means we have the 1 plus square root of x squared. So that will be 1 plus x times derivative of x raised to the power of half. So that will be half times x raised to the power of half minus 1. So that means our final solution will be equals to, so let's rewrite everything. We have e raised to the power of tangent inverse of square root of x divided by 2 times square root of x multiplied to 1 plus x. So this is the final solution.